I am handing the whiteboard to Michael for this episode. Go for it.
Thanks, Erica. All right, everyone, I have been looking forward to this one. Let us get into it. I am Michael, your guest host for this episode. Physical security is the foundation that every digital control rests on. No firewall, no encryption, no access control system survives an attacker who has unrestricted physical access to the hardware.
Domain 3 covers this explicitly because CISSP architects are expected to design from the ground up, from site selection and building layout through to the server room door. The physical layer is not just an IT concern. It is a risk management discipline.
And the OV Cloud fire of 2020, one is our case study. An entire data center was destroyed, and another was partially damaged, not by attackers, but by a fire suppression system that was inadequate for the density of equipment being protected. Physical controls matter.
Stick around for the OV Cloud fire case study later in this video. The data center destroyed not by attackers but by inadequate fire suppression. 9 concepts covering site selection, CPTED, physical layers, fire suppression, environmental controls, and power.
Starting with site selection. The decisions made before a building is designed that determine whether physical security is even achievable. Erica and Bella and Fenrir. Some of these criteria will surprise you.
Let us walk through the full physical security domain from the outside in. Starting with site selection and working our way to the server room.
Let me introduce the team real quick.
I am excited to watch this one unfold. I will jump in when I cannot help myself.
Hi, I'm Bella. I went down a rabbit hole last night and I have thoughts.
Fenrir. I always look for the part nobody talks about. Found it.
Great team. Let us get into it.
Site selection determines the risk envelope before any security control is applied. A data center in a floodplain has a physical vulnerability that no technical control can eliminate. The first physical security decision is, where do we build?
Natural disaster risk is the first filter. Floodplains add inundation risk. Earthquake fault zones add seismic risk. Hurricane corridors add wind and storm surge. FEMA flood maps and USGS seismic hazard maps are your primary reference data.
Proximity risks are equally important. A facility near an airport is in the flight approach path. Crash risk is non-trivial. Proximity to chemical plants or refineries creates hazardous materials exposure risk. A highway adjacent to the facility increases vehicle-borne attack probability.
Utilities deserve specific attention. Power is the most critical utility for data centers. The ideal site has dual power feeds from geographically separate substations, so that a single utility failure does not cut all power. Municipal water is needed for cooling systems, queue and fire suppression.
Visibility is a security consideration too, Bella. A data center with obvious external branding and clear access roads is easier to target. Low-profile facilities with minimal external signage and controlled approach routes are harder to physically attack or stake out.
And data sovereignty and regulatory requirements may constrain site geography entirely. GDPR requires that EU personal data remain in designated jurisdictions. Government-classified facilities may require specific geographic constraints. Legal requirements can override site selection optimization.
For the exam, Erica and Bella's site selection criteria include natural disaster risk, proximity risks, utility reliability, visibility and targeting risk, and regulatory constraints. These are evaluated before any physical security control is designed.
CPTED, crime prevention through environmental design, is the principle that physical space design can inherently reduce crime and unauthorized access. Rather than relying solely on guards and locks, CPED uses the environment itself as a deterrent.
Natural surveillance is the first principle design spaces so that occupants can observe each other and the surrounding area. Open sight lines, windows positioned to overlook entry areas, and reception desks placed near entrances all implement natural surveillance without dedicated security staff.
Natural access control uses physical design to guide people through intended paths. Paths, gates, and landscaping channel foot traffic through controlled entry points rather than allowing free movement across a facility perimeter. The environment itself steers people toward checkpoints.
Territorial reinforcement communicates clear ownership boundaries. Signage, fencing, landscaping changes, and pavement markings signal where public space ends and private space begins. When boundaries are ambiguous, unauthorized entry is easier to rationalize. Clear boundaries deter casual trespass.
Quick question. Does that mean CPTED is really just about cameras and guards placed in the right spots?
Not quite, Bella. CPTED is about the design of the physical environment itself, no cameras or guards required. Sight lines, landscaping, and lighting are the tools. A well-designed CPTED environment reduces the need for compensating controls like guards.
Maintenance is part of that same principle. Broken windows, overgrown landscaping, and poorly maintained fencing signal a space is not actively monitored. Attackers look for neglect. A well-maintained perimeter signals active attention.
Lighting is one of the most cost-effective CPTED implementations. Adequate lighting at all entry points, parking areas, and perimeter paths eliminates the concealment that dark areas provide. Motion. Activated lighting adds a deterrent effect by drawing attention to movement.
For the exam, Erica and Bella's CPTED principles are natural surveillance, natural access control, territorial reinforcement, and maintenance. These design-level controls reduce the need for compensating controls and are applied at the building design stage. Physical security follows the same defense, in-depth principle as logical security, multiple independent layers such that a breach in one does not grant access to the most sensitive assets. Each layer adds time, cost, and difficulty for the attacker.
The outermost layer is the perimeter fencing, bollards to prevent vehicle ramming, adequate lighting, CCTV surveillance of all perimeter areas, and guard patrols where warranted. The perimeter deters and detects rather than stops a determined attacker alone.
The building exterior layer hardens the physical structure steel, reinforced doors with access control, mantrap vestibules at main entrances, visitor management at the reception point. A mantrap forces one person through at a time, preventing tailgating by making simultaneous entry physically impossible.
The interior workspace layer segments the building, badge readers on office areas, visitor escort policies beyond reception, security zones that prevent a visitor from wandering into sensitive areas. Not everyone with building access should have equal interior access.
The innermost layer, the server room or data vault, uses the strongest controls: biometrics, two-factor authentication, man-trap entry, and in high-security environments, Faraday cage construction to prevent electromagnetic emissions from leaking outside the room.
The mantrap is worth emphasizing because it appears frequently on the exam. A mantrap, also called a vestibule or airlock, is a small room between two locked doors where only one door can open at a time. An individual enters, the outer door locks behind them. Identity is verified, then the inner door opens.
For the exam, Bella's perimeter, building, workspace, server room, 4 layers. Defense in depth means an attacker who bypasses the perimeter still faces the building layer. Mantrap prevents tailgating by enforcing one at a time entry with verification between the doors.
In March 2021, OVA Cloud's SPG2 data center in Strasbourg, France was destroyed by fire. The adjacent SPG1 facility was partially damaged. OV Cloud is one of Europe's largest cloud providers, and thousands of customers lost data, some permanently.
The fire is believed to have originated in a UPS unit, precisely the component designed to protect against power failures. The fire spread rapidly through the facility due to the high density of cabling and inadequate fire compartmentalization between server rooms.
The fire suppression system was simply not adequate for the density of equipment and cabling in the facility. Server rooms contain enormous amounts of combustible material, plastic, jacketed cables, foam packaging, cardboard. The suppression system must be designed for the actual thermal load, not just rated for the floor area.
The customer impact was compounded by backup strategy. OV Cloud offered backup services, but backups stored in the same data center were destroyed with the primary data. Customers who assumed geographic diversity of their backups did not have it. Off-site backup storage is not optional for availability.
The compartmentalization failure is the exam critical point. Fire suppression in data centers must be designed to contain fire within zones, preventing spread from one server room to adjacent areas. Proper firewalls, fire-rated cable penetrations, and independent suppression systems per zone are all required.
For the CISSP exam, Michael and Bella, remember this one. The OV Cloud Fire demonstrates that availability is a physical security property, not just an IT architecture concern. Redundancy, off-site backups, fire suppression matching actual equipment density, and compartmentalization are all required.
The UPS as a fire source is an irony worth noting for the exam. The availability control became the availability threat. Physical security controls must themselves be evaluated for failure modes. A UPS fire is a known risk. The suppression system must account for it. Okay, it is quiz time. Let's find out what stuck. Think through each question carefully before you answer.
If this is clicking for you, smash that like button and hit subscribe. It keeps this series alive.
A data center requires a fire suppression system that minimizes the risk of accidental water discharge damaging equipment while still providing water-based protection. Which system is most appropriate? The correct answer is B. Preaction requires two independent triggers before releasing water, preventing accidental discharge.
Which CPTED principle is most directly implemented by positioning the reception desk to provide clear sight lines to building entrances? The correct answer is D, natural surveillance, designing spaces so occupants can observe activity without dedicated security staff.
A facility's power design uses a single utility feed connected to a UPS and diesel generator. Which availability risk does this configuration fail to address? The correct answer is A, utility substation single point of failure. A fault at the single substation cuts power despite UPS and generator.
Great work on the physical security quiz. Here is what we built today. Physical security uses defense in depth with 4 layers: perimeter, building, workspace, and server room. Each layer uses different controls. Failure of one does not grant access to the next.
CPTED principles: natural surveillance, access control, territorial reinforcement, and maintenance. Site selection must account for natural disaster risk, proximity hazards, utility reliability, and regulatory constraints. These decisions happen before the building is designed.
Fire suppression wet pipe is fastest but not server, room appropriate. Dry pipe is slower. Pre-action requires 2 triggers, the server room standard for water-based systems. Clean agents like FM 200 protect equipment without water damage.
The OV Cloud fire showed that when physical controls fail, digital controls are irrelevant. Fire suppression must match equipment density. Backups must be off-site. UPS units themselves can be fire sources. Physical security is not a box to check, it is a discipline to maintain.
Next is CISSP 3.7 Physical Access Controls. Fences, locks, biometrics, CCTV, badges, visitor management, and tailgating prevention. Subscribe and keep the playlist going.
Think in pictures, and the answers follow. Think in pictures, and the answers follow.
Michael, that was excellent. I am going to need my whiteboard back though. Professor Erica, signing off.